Remember, part of the intention of using the quadratic formula is to solve those equations that would not be easily solved using some other strategy. Equations that we can't factor and solve, equations that we can't easily graph and find the solutions, and equations where we can't use the square root method. It is also especially valuable in those situations where the solutions are imaginary. So we want to look at an example of that. We begin again by setting our equation equal to 0, writing the equation in standard form from highest power down to lowest power. We have values of a, b, and c as 3, 4, and 2. And we substitute those into the quadratic formula. Opposite of b, plus or minus the square root of b squared minus 4ac, and all of that over 2 times 3. That'll transition to -4 plus or minus the square root of 16 minus 24. All of that over 6. -4 plus or minus 16 minus 24 is -8 over 6. And at this point, back in your experiences in Algebra 1 or even before the end of Module 7 in this course, you would have looked at this particular answer and thought, well, I'm done. I have no mechanism for finding the square root of -8. I'm going to leave this alone and say that this particular equation has no real solutions. And you wouldn't be wrong. It does not have any real solutions. But now that we have a strategy for dealing with the square root of a negative number, i.e. the imaginary numbers, we can continue our simplifying. -4 plus or minus. We take the square root of 8, which is 2 root 2, and we know that it has an imaginary part, I. All of our terms in this equation, in this expression here, are all divisible by 2. So we're going to divide everybody by 2. It's like we're dividing a 2 out of the denominator, and we have -2 plus minus root 2i, all of that over 3. Now, you might remember from our work in Module 7 that we like to have the imaginary part and the real part of the number separated. Fortunately for us, we have just this lone term denominator, so it would be pretty easy for us to split it. We have -2/3 plus root 2 over 3i as one solution, and -2/3 minus root 2 over 3i as the other solution. So while we have no real solutions, our strategy for writing and thinking about imaginary numbers allows us to have an imaginary solution to the equation. So if I was to place either one of these as the potential value for x into the original equation, I should expect there to be a true statement. Again, thinking about our work with complex numbers, we added an extra layer to the quadratic formula that allows us to step beyond the no real solutions problem and answer our question with some complex imaginary numbers.